Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over how to write nuclear equations. So let's get into this. So the key to writing nuclear equations is one, you got to identify what particle is being released or gained or absorbed by the nuclide, the parent nuclei. And then after that, once you set it up, you need to make sure that you balance the numbers on both sides of the equation. So the total numbers on top should be equal to each other, and the total numbers on the bottom should be equal to each other. So let's get started on this. So for A, we're told that the alpha emission is gone. Polonium 210 atom undergoes alpha emission. And so we know that the parent atom or nuclide that we're talking about is polonium 210. The 210 is the mass number. So we can write our symbol as the following. So PO, we know the mass number is 210. And then to get the atomic number for the bottom, we just look on a periodic table for polonium. And we have, where are you? 84. So then the bottom number here is 84. Okay, so it's going to undergo an alpha emission. So this is the only reactant. So this is going to decay into something else plus an alpha particle. So you have to know that if you undergo alpha emission, then one of the products is an alpha particle, and you have to know what an alpha particle is. Alpha particle is a helium nucleus. So you can write this, you can symbolize this as He, and then that's going to have a mass of 4, a mass number of 4, and it has 2 protons, so it's atomic number 2. Okay, so then we have to finish this up. So some other daughter isotope is produced, right? So we need to make sure that this plus this gives us the same numbers on this side. So the total here is 210. So here I have a 4. 4 plus what gives me 210? It would be 206, right? We get 206 if you take the 4 here, subtract it from the total on this side, we get 206. So 206 is the top number. So 206 plus 4 gives us 210. So here we have 2 here. The total bottom number is 84. So 2 plus what gives us 84? 82. So 82 is going to be our bottom number. And again, you can get that by taking the 2 here and subtracting it from the total on this side, 84, you get 82. Now that we have the atomic number, we can look up the symbol for this daughter isotope. So we look up 82 and we have lead, Pb. So the symbol Pb. So that is the nuclear equation for this decay. Okay, so for B, we're told that beta emission, there's beta emission gone by gold 198. So gold 198, gold 198, excuse me, is undergoing beta emission. So here we need to understand, well, beta emission means you're giving off a beta particle. So this is going to decay, giving off a beta particle, and then it's going to have a daughter isotope left over. We have to figure out what that daughter isotope is. But we know the parent isotope is gold 198. So we're going to start with that. So Au is the symbol for gold. So we have Au. And then 198 is the mass number. So 198 on top. Look up the atomic number on your periodic table. So we look up gold, and it is atomic number 79. So 79 goes on the bottom there. So this is going to undergo a decay, in this case, beta decay. So it's going to emit a beta particle. You have to know what the symbol of a beta, you have to know what a beta particle is, right? A beta particle is just an electron, basically. So it's a negative electron. So that was kind of redundant because electrons are negative. Anyway, so the symbol for a beta particle is going to be E for electron, and the top mass number is going to be 0, and the bottom number is going to be -1. So there's our symbol. So now we need to make sure that our missing daughter isotope plus the beta particle equals everything on this side. So again, the top numbers on both sides should be equal. The bottom numbers on both sides should be equal. The total should be equal. So here on this side, we have a total of 198. Here we have 0. 0 plus what gives me 198? 198. Right, so we have 198, and again, you could do this by subtracting the top number from the total on this side. The total here is 198. 198 minus 0 is 198. Now here we have a -1, and we have 79 for the total. So -1 plus what gives us 79? Or another way to put it is what minus 1 gives us 79. So that would be 80. Right. And again, you could take this number and subtract it from the 79. 79 minus -1. A minus of a negative is going to be a positive. So you add 1 to 79, you get 80. So now that we have the bottom number, that's our atomic number. We looked that up on our periodic table, number 80, and we get mercury, Hg. So that is the daughter isotope of this decay process. Okay, so next we have positron emission by nitrogen 13. So positron, what is a positron? You got to know what a positron is. It's basically a positive electron. So it's going to be this symbol, but with a +1 instead of a -1. So we're going to emit a particle. So this means it's a product. So emission means you're producing that as a product. So our only reactant is the nitrogen 13. So we'll have N and then 13 as the mass number. Look up the atomic number for nitrogen, and we get 7 from the periodic table. So that's going to be a 7 on the bottom. And then that's going to decay by positron emission. So we said that it's a positive electron, hence positron. And then that's going to be a +1 on the bottom and a 0 on top. So let's make sure that this is 0. Okay, now that we have our positron, we got to figure out what the daughter isotope is. And again, the top numbers on both sides, the total should be equal. So the total here is 13. So 0 plus what gives me 13? 13. And then here we have 7. Well, what plus 1 gives me 7? That would be 6. And so now I know 6 is the atomic number. I look up atomic number 6, and I have carbon. So this is carbon 13 now. And so here's our nuclear equation for this description, this decay. And then finally, we have electron capture by gallium-67. So in this case, we're capturing, right? So we're not emitting anything. We're going to capture and absorb that into us, right? So that's the gallium. That's what gallium-67 is going to do. So in this case, we have two reactants. We have the electron plus the gallium-67, and they're going to combine to form a new daughter isotope. So we'll write the gallium-67. So that's going to be Ga, and 67 is the mass number. We look up Ga, and that's number 31. So that's the atomic number plus the electron that it's going to capture. So again, the symbol for the electron is E with 0 mass number and -1 for the atomic number, the bottom number. Okay, now that's going to produce what? Well, we got to add up the two numbers here. So 0 plus 67 gives us 67. And then the bottom numbers here, 31 minus 1 gives us 30. And so we look up number 30 on the periodic table, and we get zinc. So Zn. And there you go. So here we have our new daughter isotope. So here I want to point out a couple of things that are really interesting that I want you to make sure you know. So here we're adding an electron to our atom, but notice what happens to the number of protons. The number of protons decreases. So we go from 31 to 30. So we lost a proton when we gained the electron. Well, wait a minute. What happened? Where did the proton go? Well, if you notice, the mass number stayed the same. Well, how can the mass number stay the same if you lost a proton? It should go down, right? Not if you gained a neutron. So what happened here is an electron was absorbed into the nucleus, combined with a proton, formed a neutron. Okay, mind-blowing, right? Okay, what else? So here you lose an electron, right? You emit an electron, and you see that the the atomic number increased by 1. So we're going in the opposite direction. So here you gain a proton by losing an electron. So, but the mass number stayed the same. So where did this electron come from? Well, how did we gain the proton? Well, if the mass number stays the same, we must have lost a neutron. So in this case, the neutron broke apart into a proton and electron. So we gained a proton and we lost the electron, and our mass number stayed the same. So again, these are, this shows that the subatomic particles themselves are not, they're not solids, they're made up of particles themselves. So again, I just wanted to make sure that was clear. If you enjoyed this video, if you learned a lot from this video, if you learned anything from this video, please like the video, share the video with your friends, hit the like button. Also, make sure that you subscribe to my channel. And when you do, make sure that you click on the notification bell and click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. Also, if you have a problem or a question you want me to go over, please put that down in the comment section. If you have a topic you want me to cover, put that down in the comment sections. Sorry. I would love to do that for you. Thanks for joining me, and have a great day.